which will contain 30 that will represent the public interest in the investigation into the potential positive and mitigation features of landslide-dammed lake, which will contain 34.
Hello everyone, this is Sean. I'm Yoko. Thank you for inviting us here, and this is our presentation. Please enjoy it. We all know that Hawaii experienced an unprecedented great disaster. This marked the first large-scale barrier lake breach in Taiwan since the village tragedy in 2009. Because Taiwan is situated on a volcanic and seismic belt, and we also have narrow river valley and deep river beds. So Taiwan is actually highly prone to landslides. And combined with extreme weather and frequent typhoon and massive discharge in the catchment areas, these factors make barrier lake lifespan short. And we found this data from the Ministry of Agriculture. And regarding 89 barrier lakes in Taiwan, we analyzed this bar chart. And we found that 11.2% of the barrier lakes breached within a day, while 24.7% lasted less than a week. Let's use a time approach to explore how Taiwan can minimize the damage and prevent such tragedies from happening again. And first is the prevention phase. And in July, Typhoon Biffa triggered the formation of the barrier lake. While initially stable, the frequent typhoon caused heavy rainfall in September hit us unprepared. And this should be a video. Thanks. Okay. And according to our calculation based on the open data from the government, we found that 36.0% are caused by typhoons, while 22.5% are caused by earthquakes. Because of this, we would like to overlay large-scale landslide potential zones, which was investigated by the government, and also the fault zone. This area are highly prone to trigger earthquakes, and also river channel with slopes under 20 degrees. Because the slopes was too steep, the dam won't form. And to create a barrier lake formation risk map. This would allow for early monitoring and soil conservation and slope management, and also strengthening the disaster awareness for mountain communities. And second is the detection and monitoring. And following a disaster, experts use simulation systems to predict where they will form, but however, the actual confirmation still relies on satellite imagery and aerial photography. To defy gravity, satellites are far from the ground, so they suffer from low resolution. And also the orbital period of satellites is different from that of the Earth's rotation, so it's delayed in getting an image. While drones, on the other hand, low flexible, but they have suffered from the limited battery lifespan. And this is the satellite image, and this is aerial photography. We hope to use automated battery swapping and drones to place fixed camera and solar panels to maintain long-term monitoring and avoid exposing maintenance labor to dangers. And also, furthermore, while Japan previously provided water level gauges to Taiwan, their performance has been inconsistent. From the delay or local terrain. So for public safety, it is essential for Taiwan to invest the equipment that is suitable for Taiwan in rugged mountain environment.
The next step is to conduct a thin body assessment. Since engineering solutions are impossible due to these four reasons, we must focus on monitoring the sites providing early warnings, and ensure everyone downstream can evacuate safely. So we can use this table to counting the numbers and locations of the downstream residents. That will allow them to complete the evacuations as quickly as possible. The next stage is reaching the failure point is the disaster period of defining the casualties. When we look at where these risks are and who live in there, we can see a clear pattern that most high-risk flood areas are in remote places. Unfortunately, the people living there are more vulnerable and have the fewest resources to deal with the disaster. Take Guangdong Township as an example. First, we can see that more than half of the populations are indigenous people. Also, migrant workers make up about 16% of the population. The people in this group may face language or information barriers, so they may not receive or fully understand the warnings as quickly as others. Next, if we look at the age structure chart, we can see that about 1/3 of the population are elderly people. Due to physical limitations or information barriers, elderly people may have more difficulties to move in quickly or responding to emergencies. When we put these two factors together, we can see that a large part of the community may face information or physical or communication challenges. So in an emergency, such as embankment breach, these people are more likely to be left behind. And another problem is most people don't really understand the landslide-dammed and most people don't really understand the risk of landslide damage because we get some alerts on our phones, so we started to ignore them. This is called alert fatigue. This makes us to miss the best time to evacuate safely. So to solve these issues, we should doing detailed surveys to the public to find people who need extra help, such as those with physical or mobility issues, so that when in emergencies, we can provide the right support during evacuations. Next, by working with locals and tribal groups, we can reach in the community in a more flexible way. Also, we should publish our landslide damage data so our residents can keep informed. They won't ignore the alert anymore. So, they will ignore our alert anymore. They can evacuate safely in the first time. Next is the post-disaster recovery. The massive volume of skills that after a failure is the big challenges of recovery. These skills can basically be divided into two types. First, useful gravel and sand, which can be given to builders as important building material. Second, high moisture clay, which can be used as good soil for farming. However, if this clay gets mixed with trash or sand, it can only be sorted and burned. On top of these recycling issues, these disaster sites almost often in among places that we just stayed, and these fields in local is more than the local building activities. Take Matian River as an example. The construction demand in eastern Taiwan is more than the construction demand in eastern Taiwan is far lower than in the west, but it is too expensive to ship in these materials to the west. So to deal with these issues, we propose bringing mobile crushing and screening plants directly to disaster sites. This technology allows us to perform an initial screening on site without, and the main The main advantage is it can. The main advantage is it can. The main advantage is it can. That is maximizing the resources to the local rebuilding without the high shipping cost. But we must note that this process material isn't strong enough for major buildings and can only be used in road foundation and hydraulic engineering.
Okay, to sum up, we try to create a very risk map, and we previously use Canva to reduce transparency for our visuals, but in the future, we hope to use GX system to achieve more precise and the mapping analysis. And in the second phase, detection monitoring, we hope to use solar panels and drones to place fixed cameras and without exposing maintenance labor to danger. And it is essential for us to invest the equipment that needs to go for Taiwan. And third, in the evacuation phase, we must first investigate the population structure and distribution, and to know the specific needs during the evacuation and in daily life. And we should increase public awareness and also remain data open and transparent. And that's one is recovery phase. We hope to develop mobile crushing and screening plant in the future, and also how government can assist in finding local construction companies to purchase waste oil, and also maximizing its utility and using it in local construction projects.
And this is our presentation. We want to dedicate this presentation to those who participate in this disaster and relieve their efforts. Thank you, everyone.
Questions from our audience? Yes. So, can you help me? First of all, very great. And you have the insight to be like pay attention to some of the natural disasters that we need to face and we need to solve it. So, can you walk me through again how did you use the data analysis skills to help you with this analysis?
And first, we
like what data have you collected, and then like how the data help you to run through like what the preventions or different stages that can help to release the disaster, the outcome, like the data collections or data analysis stage. Can you give me a little bit more explanations on
that? First is the how long is the related lifespan? How long, like it collected from the Ministry of Agriculture, and
do you mean how do we collect this data?
Yes, it could be part of it because like for data analysis, because this topic is more for data analysis. So part of like data collection is one of the things as well. So if you can demonstrate a bit more like how, if you want to like walk us through like how do you do the data collections, or how did you use the data to come up with these preventions?
Or maybe you can talk a little bit about GIS.
So we hope to use it because we asked our geography teacher, but that is too hard for us.
And we use the government platform to search in this data, and because we think the government platform more
Reliable.
Yeah, they reliable.
The questions or details that our judges want to know more? Okay, thank you very much.